So I'm just starting the recording, Dennis. You can go ahead. Thank you for your time and happy to see you again. And we have quite a number of people attending today. That's cool. So, Dennis,
Okay, so
floor is yours.
thank you for inviting me. So what I'll do is like a 25-minute presentation, and then you can ask me all the questions you want. So the idea today is to explore the future with AI transformers. So I'll just introduce myself a minute. I'm an artificial intelligence expert. I wrote many artificial algorithms. I registered patents. I have a university background at the Sorbonne, which means I like to share a lot, and I like people to share with me. So I worked for years, like for IBM or large corporations delivering AI. In fact, I've delivered AI all my life. So that's basically my experience. I'm going briefly because you can find my profile on LinkedIn. You can find the books on Amazon. Just type Denis Rothman. I'd like to dive into the topic. So what we're going to do today is there's going to be three parts. First, we're going to explore the state-of-art capabilities of a transformer, looking at natural language processing, software development, image generation analysis. Then we're going to peek into the architecture to see how this works. And then we'll go into a supply chain use case. How can this be used with supply chains? Okay, so let's go ahead. All right, to the next slide. So we're going to go look, first we're going to start with natural language. Now, I'll just give you keywords that you need to remember. Emergence. See, that's that little word on the bottom here. Emergence. That is a key word. I don't want to drown you in a lot of words that you won't remember 5 minutes after the presentation. Remember emergence. Emergence means that a language model like GPT, GPT-4, or other, will learn to understand a language, but it's not necessarily learning how to do a lot of tasks. It'll learn a lot of sequences. It'll be able to predict the next word. So emergence means that at one point, it will do tasks it wasn't trained for. Now, it's both a potential and something we have to watch out for, because it can do a lot of things. Like when you go ask ChatGPT to summarize a text, it never learned how to summarize a text, or it never learned how to answer questions. It just learned how to understand sequences, because it doesn't work like us. We'll see that. Okay, so here's a key term. Emergence means that it's doing a lot of things are coming out of the system that it didn't learn. This image here was generated, by the way, by DALL-E 2 OpenAI, okay, which is a transformer too. So here, I'm putting up a slide where ChatGPT explains itself. It's just to show you that the system is beginning to be able to explain itself and to write a lot of text, right? So it's just explaining what it is. It can do anything it wants. It's powered by architectures like GPT-4. Okay, then you see another important word that's coming up here in the middle, generative AI. Okay, so we were speaking about emergence, and then all of a sudden we have this new term. So that's another term to remember, is generative AI. What does that mean? It means that the system didn't learn to do a specific task. It's just generating the next word, or the next part of an image, or the next part of a sound. Now it seems incredible, but that's all it does. It's like when I say, let's drive downtown. So let's go into my car, right? So all it learns is that. So you say, if you stop the sentence, let's go into my, it will find car. But then it can go on for thousands of words. It's just these are statistics. So generative AI is quite different from the rest of AI in the fact that it will generate sequences. That's what's very different from other deep learning models that will do classification. Like this is a cat, this is a dog, or this is how you can open a machine or something if it was trained to do something. Here it will do things it wasn't trained for. Remember, emergence and generative AI. So you can do anything with it. You can translate, you can do writing, you can have a virtual assistant. It's spreading out at full speed because you have this in Google Workspace. It's coming out in Microsoft 365. Mainstream users are becoming artificial intelligence experts. Okay, then we go here, and so I was showing how it could do things in terms of text, but it can also write code. For example, what you're looking at was produced by GPT 3.5 Turbo. That is, in fact, the old version of GPT-4. Okay, so GPT, as you know it, doesn't exist anymore. GPT, the first version, came out on November 30th, 2022. It was a GPT 3.5 model. It was replaced then by a GPT 3.5 Turbo model, and it disappeared. It doesn't exist. It's deprecated. So many people are speaking about ChatGPT, are speaking about an umbrella term of a system that doesn't exist. So someone speaking about what happened in November, January, or February when they were testing it, it's gone. It doesn't exist anymore. It's not even available. So now we have GPT 3.5 Turbo that's left in GPT-4, and I suspect that in the near future, GPT 3.5 won't exist anymore, only GPT-4. So we're speaking about a whole new system, and it wrote this whole program by itself. Okay, it's a classification problem, and it wrote the code to show how, and even the confusion matrix. So and here is how it does it. Okay, it will write the code by itself again. Okay, if we go here. Okay, so first let me go back. It explains what it's doing. This is totally written by GPT-4. It is writing a full text on how to create a classification algorithm in machine learning, and it wrote the whole thing itself. Okay, it wrote the explanation. Once it wrote the explanation, okay, it gives you the code. Okay, it writes the code by itself. So what you're seeing here is a new generation. It's a total new generation of AI. We first saw that it can write text by itself. Now we can see that it can explain, like a teacher, a code, then it can write the code, and then you can run the code like the images I showed you. So you can see that we're dealing with something very unusual. It's a big paradigm change. It's going to affect white collars essentially. If you're a plumber or a stonemason, you don't care. But if you're a developer, either you learn how to harness this technology very quickly, or you're going to be overtaken not by AI, but by mainstream users that are on Microsoft 365 or that are on Google Workspace. Meaning it's going out into Word, it's going out into Excel, it's going out to everything an IT department doesn't like is when users are developing things themselves. So if they're asking for something, say, can you give me a system that can classify the sales last month? And you say, I don't have time. Someone's going to go type it in GPT Plus or in their Word environment or anywhere, and they'll get it. And in fact, they can even go, if someone has a Google account, they get a free VM, and they can even run the code on a free VM. So it's getting to a point where IT people are trapped on both sides. What I mean is we have big tech that has the big deep pockets to build these systems and then charge us to use them, what pay as you go. And the other side, we have these mainstream end users that are building up their potential with systems they don't understand, but they can get to work like a phone. So it's a new world. There's a lot of room for experts. I seriously doubt that humans won't be needed. Okay, but it's going to be challenging for those who are not upskilling. So before we go on like that to like supply chains, I'm not going to go deep into that. You can see that it can develop and create images. Now, these images are extremely well designed. I mean, if you really know how to ask the system what to do, you get incredible images. So you're saying, yeah, but you're making nice pictures, but what for? Now, just as I showed you that Microsoft is rolling out this technology everywhere, Microsoft just rolled it out into Microsoft Designer, which is on the web, and it can create anything you want. Your logos, images for PowerPoints, presentations. So right now, it's this trap I'm speaking about. Experts are being trapped between big tech that's going so fast it's very difficult to keep up. On the other side, mainstream users, they're just popping up using it because with Workspace, Google Workspace, you just pay like $30 a month and you get all of it. And you go, it's not that expensive. In fact, it's very cheap for a mainstream end user that's not using huge volumes. Since they're always using small volumes, I use these systems intensively in different platforms like Google, Amazon, whatever, and it never adds up to a lot of money because I'm using small amounts of data. For a corporation, it's no problem because the budget is there. So we're trapped again. So in this chapter, if you have a look at chapter 17 in the latest version of my book on Amazon, I wrote a chapter where the system, it does it all alone. It'll install OpenAI. It will check if the content is safe with a moderation model. It'll prepare a prompt for ChatGPT. It'll write a poem. It'll illustrate the poem, and you can listen to the poem with Google to text, and you can listen to the transcription with Whisper. You just click on one button, it'll do all that. Now, if someone told us that, I would say even 3 years ago, no one would believe it. So now we get to another topic, right? This is another one. This is Hugging GPT, which I call a developmental company. It's Hugging Face, which is also trapped between big tech and small users, but it's pretty nice. It's not as powerful as OpenAI, but you can get a lot of explanation, like what model it used. The description explains the description. It's very interesting to use, and it doesn't cost that much. But there's a price too because now they're hosted on Amazon. So as soon as you use this, you pay, and you pay by the hour. Okay. So if you try all that, you have a budget. So here, let's understand, let's go into the architecture a bit to see what's going on. Where does this mystery come from? Now it's extremely simple in terms of algorithms. It's taking every word in a sequence and comparing it to every other word. It's like saying, I am talking, or let's take this understanding state-of-art transform art. It will take understanding with architecture, understanding with transformers with SOA. It's like in the old days when we wrote a loop comparing two columns of or an SQL script that does it. It'll compare everything and it'll give a weight. It will say understanding what's important in there, transformers. Okay, so when it sees transformers in architecture, it'll say maybe understanding is a good potential word. So it'll do a lot of statistics. So how did it even build up to something like that. It builds up because it's doing the same thing. It's distributed calculations. Like here you can see 612. It can use, it's not exactly that because it's more complex, but let's imagine you have 12 GPUs, and each GPU is trying to understand the exact same sequence in a different way. So you're talking about hardware. For me, these transformers are hardware driven because they can use the potential of parallel processing on huge computers. Okay, we're talking about like GPT-3 trained on 10,000 GPUs and 30,000 CPUs. That's possible because you're doing a very small thing, comparing words to one another in a sequence, and you're distributing it over the GPUs, and they don't need to communicate with each other. They're just learning something, and it'll put it together at the end of the calculation. That's only one layer. I'm speaking about one layer. There are 96 layers in GPT-3, and there are 175 billion parameters. Now, right now, I'm testing Google Palm, which has 540 billion parameters, and it was trained on 6,144 TPU chips. So when people say I'm going to train a model, sure, go ahead. 6,144 TPU chips from Google is like 10,000 GPUs from NVIDIA. So if you have, it takes quite a budget. So what I'm saying is, these are huge models, so they can fit statistics in there as much as they want. Okay, so just what you have to bear in mind is it's looking at everything in a sentence in every possible way, in every possible context. Okay, now.
Just one question, Denis.
Sure.
Is there, okay, I understand there may be more technical people and less technical people in the audience, maybe. Is there any intuition that you can use to explain why this architecture is working and not another one? Or, you know?
Yeah, okay. So let's imagine that, let's take an example. Let's take an example. Let's imagine you're picking up tomatoes in your garden. Okay. So you're looking at your tomatoes in your garden, and you're going from one plant to another. And let's say you don't want to pick them right now because the sun hasn't shined much. Some are green, some are red. So now you're walking from one tomato to another. And now I'm going to add, there are 50 tomatoes. And when you look at the first tomato, I'm going to ask you to memorize what you saw on the first tomato. You go to the second one. Then I'll ask you to memorize at the third. Anyone in this audience will be lost after 5 tomatoes. No one will be able to tell me what happened with the first tomato because it's overloading our memory. We can see 2 tomatoes, but how can we memorize 50 tomatoes? And the fact is that old software would do that. The previous model of transformers would try to memorize everything. So you'd have they'd pile it up and explode the memory. So you would explode your available memory trying to remember everything. So you're piling up, let's say we take this sentence, GPT-3, okay, I remember it. Has what? Oh, GPT-3. So now it's going to memorize, the old system would memorize all the words in that order and pile up these vectors and these matrices which so huge, well, they couldn't go far. The machines would slow down, you couldn't go far. How far can you remember? A machine can't either. Now Transformer did away with that. So I don't want to remember anything. I'm not going to remember anything at all. I'm not going to overload my memory. I'm going to say this word weighs more than that word, and I'll just store that. I don't care. I don't care which word came first. I don't care which word came after. I'll just say this tomato is red, this tomato is green, this tomato is red, and I'll store that information. But there's a little trick, is that if I see a green tomato and I know there's a red tomato behind it, I will have learned in time that green follows red. It's just a weight. It's just like it's like training, like you look at a dog or a cat. If you look at a dog, it doesn't remember much, but it can make a decision. If it sees someone it doesn't like, it'll bark. And it doesn't have to remember like 100 people. It could just smell. So what I'm saying is it stores a lot less as it goes along through the calculation.
Hmm.
And why is it comparing it like that? Because it's just storing weights. This goes with that, this goes with that. It's not remembering anything. It's just storing a weight. It's
Okay.
saying attention. Let's say take the word attention head. Well, head will be weigh like 5 and attention will weigh 2. So when attention gets there, they say, what's the best word? Head. It's just probabilities.
You just
It'll just say that's the best word. It's like alphabetical order, but with numbers.
Okay. Yeah.
Is that better?
Yeah, but this is like you said, right? It's statistics, right? The larger the model, the better chance you have to model the knowledge, right? So, but it's not clever, right?
No, there's nothing in there.
Yeah, exactly.
If
Exactly.
you're looking for intelligence, you're not going to find any.
Exactly. Yeah, that's what. Okay.
You're not going to find any intelligence at all. It's statistics.
Hmm.
Like everyone here probably has heard statistics, like uh, polls, like who's going to be elected president, or it's statistics. So this candidate weighs more in the polls than that candidate, so we're going to say he's going to win. It's just weighing. It's just a weights between words and storing them, and then pulling the probabilities out.
Yeah.
There's no intelligence in there. There's no reasoning. There's no rule bases. There's no instinct. There's nothing but a simple equation of probabilities that you store, like apples in France or apples in the Sahara Desert. Well, what's the most probability that you'll find apples somewhere is in France. So I'll just say, apples in France. So France will be a big probability. Sahara will be a lower probability.
Hmm.
That's it.
Yeah.
Now, if you're looking for something else, you'll never find it. It's like trying to take your laptop apart and see if there's someone in there.
Hmm. Yeah.
There's nothing in there. It's empty. It's just statistics. But
Yeah.
the statistics of these machines are so powerful that they can capture like billion parameter language model. Okay, so if you see billion parameter language, it has learned through billions of calculations that if language parameter billion come together, model is a high probability.
Yeah. Yeah.
That's all. That's all you're looking at.
Hmm.
And you can look all day for something else, you'll never find it. Now it leads to two interesting questions, philosophical questions, because I spend my days looking at this, like you. I'm saying, are we that dumb? Are human beings so dumb that we can be replaced by just a simple statistic? And then I thought of this movie, The Modern Times by Charlie Chaplin,
Hmm.
where everything was broken down into little functions. No one asked us to think in our jobs. Our jobs are cut up into little pieces of functions that are statistical. In fact, sometimes we make fun of people. When they come to the office, look, he's going to put his hat there. Look, he's going to go get his coffee. Then he's going to say hello. He's going to sit down. Then someone's going to call him. We can predict nearly whatever. So it's terrible because you can see that statistics can replace us because we keep doing these repetitive tasks in our daily lives. Now, if we were Van Gogh or Salvatore Dali, none of this would work on us because we would keep changing ideas, or Picasso. But we're just normal, ordinary people, and these systems just learn what we do and repeat it with statistics. So it's powerful, it's empty, but it's a lesson to humanity, maybe to start thinking.
In fact, before you move on, maybe we can just take a few questions because that's interesting. Somebody said, what does it mean 540 billion parameters? What these parameters look like, right?
Yeah, so these are vectors. So I'll give you a simple example. Let's say that you have an Euclidean space like when you were in high school. You have X and you have Y, okay? And at point 0, you put all the fruits. You say apple, orange, you put them all together. But now you put, I don't know, you say you put Ali, okay, a person. You put him at coordinate 1010, okay, so he's somewhere up there. And Ali likes apples, but Ali doesn't like oranges. So you'll have a specific parameter for this case. Someone likes oranges and someone likes apples, but not oranges. So one parameter is to say that apple there, I'm not going to put it at 0, 0 anymore. I'm going to move it near Ali so that when we ask for what Ali likes, it'll find apple. So you're just moving it around. Or you can even have a simpler image when you're sitting at your table and someone says, give me some salt. So someone passes the salt. So now if you look at it as a vector space, that's one parameter. We can know that Patrick likes salt. So we just store it there. And then we have another parameter that says these people don't like that kind of stuff, and then that kind and that kind. So now you get millions and millions of parameters, and you build up to billions and billions of parameters. And since what I just said, we're so simplistic, that's what worries me, not the machine that we're so simplistic that we're always repeating the same, we're always doing the same things. So it's very easy, in fact, to repeat what we're doing because we don't do much. Because I look at these billions of parameters every day and the billions, and I look at billions of posts and messages and texts it trains. We're repeating the same thing all the time. I like this book. I don't like this book. I like this game. I don't like this game. I like that. I don't like this president. I don't like this government. It's not a democracy anymore. It's a democracy. Sure it is. But if you think of it, there are not many, if you look at what people are telling you in one day, there's not that much. So these parameters are just remembering statistics. They're statistical parameters that will change the position of a word in that space. So when it sees Sahara, it will say, no, 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 no. I'm not bringing fruits near Sahara. I'm going to bring sand near Sahara. So you're speaking about weights, and they're just learning it through billions of calculations to put things that go together, and that's it. So these.
Yeah, I think you explained. There was another question that I understand the question. Said, could you please explain how a model can use mathematics or any other science without understanding it? In fact, it doesn't understand anything. It's stored.
No, doesn't understand a thing.
Yeah. Yeah. It's stored.
but we invented. Yeah, but it doesn't. I've spent hours on this topic because the more I spend on it, the more it's philosophical because there's nothing inside. But in fact, math is a sequence.
Yeah.
Math is a language. It's a universal language. If you have 2 + 2, it'll always equal 4, unless. So it's not that difficult either, but it's not that good at math. These large language models are not that good at math. They can do simple things, but if you ask them for complex things, they can't do it yet. But I've developed, now I'm not going to complicate this presentation, but I've developed other models where I add logic to the training. So you can plug other things inside of the model. Like Bing does this. If you look at new Bing, what I can do is have a transformer model, then call a function, get the answer on a scientific calculator, then ask the system to explain it in natural language because now it knows the answer. But anyway, 50% of math is just sequences. If I have y equals, there's a big probability I'm going to find f of x, or these are sequences. A lot of math are sequences. If you ask for this equation or derivatives, you can't invent derivatives. We've been repeating the same thing in math for centuries. So if it absorbs all the books of math, it can do some simple math, but it won't do complex math. It won't do the real Boltzmann calculations. You have Boltzmann in artificial intelligence, but it's just a word. It has nothing to do with the real calculations, or it's not going to calculate relativity or stuff like. It'll do simple things. So yeah. That's
There's another question because I'm just picking up questions because I might forget later, right? So
sure, go ahead.
are those models, do these models need to store all possible words of the language, or do they need to store some facts?
They don't store anything.
Okay, yeah.
They just store the weights.
They store the weights of a word in a context, or
Well, you take the word, that's the first slide on my presentation,
yeah,
I showed where I wrote a word to vector patent.
yeah.
That's in the 1980s,
Hmm.
where I understood that if I wanted to do calculations with language, I would convert them into numbers.
Vectors or numbers. Yeah.
Or yeah, vector numbers. But then that's called tokenizing and embedding. So we take the word, we convert it into a number, but we keep the memory of that word. Now, what's magic, this is going to frighten you even more. We don't store words. In models like this, we just store subwords. Like we're going to store, in training, we're going to store train and ing. We're going to store two chips. We might end up storing CH and then IPS somewhere else. In fact, they're not even words in the dictionary. It's even worse than you think. They're not even words in there. If you look at words, you only find word pieces, subwords. So that way you can have a 50,000 dictionary of subwords. And with that, you can constitute all the words that exist, because the smallest words in the dictionary are characters.
Yeah.
So you can have you have all the characters and numbers, and then you have a little bigger subwords, and then you have words. But with that, with 50,000 of these, you can cover everything in the English language. 500,000 words with just a very small dictionary of these little word pieces. And in fact, I'm showing you words here, but those are not words they're calculating piece of words. It first sees to go if train goes with training, and then training with two, and then two with a white space, with a space, then to 6, then to 1, to 44. It's extremely powerful statistics. Extremely, it's mind-blowing statistics.
Yeah, there are more questions, but maybe we can.
But you can solve your problem very easily by saying, how can a system that has no intelligence in doing pure statistics repeat what we great humans do? Well, then reverse the problem. Why don't we great humans do great things?
Yeah, that's a philosophical question.
How can we be reduced to these statistics? It's because we've been reduced for maybe 100 years, 2,000 years, into little pieces of what we do in a day. A farmer farms, a stonemason does stones. We've cut everything into little pieces, like the German Bertolt Brecht said that in the 1950s already. He said it's becoming terrifying. We're schneiding, we're cutting time into little pieces of little work. So we're very predictable, and that's something I don't like. Like if you go in a parking lot and you insult someone, there's a great chance that this person will insult you. So we're so predictable. We're going to have to be humble. You reverse the problem. How can something with no intelligence and statistics beat everyone at a lot of topics? It even the GPT-4 even passed the bar exam, the U.S. bar exam for law, and it scored among some of the best. And I have a whole list of all these exams it passed, and it passed them among the best students. That tells you a lot about what we're learning in universities. Now, if you went back to even, I would say 1850, it wouldn't work, because educated people were very literary, and it wasn't multiple choice questions. They really had to, but we've been cut into little pieces, so it's very easy to reproduce us.
That's true. Sorry.
And if you really want to understand, just go back and look at Charlie Chaplin's Modern World. Les temps modernes.
Yeah.
So here it's basically the same thing. What we're saying here is it can be used. Now, since I'll conclude with this, since and if you have more questions, it's supply chain. what is more predictable than what you're doing in a supply chain? In the warehouse, you store, then you take it out, you minimize the cost, you can improve your forecasting because humans are predictable. If it's raining, people are going to buy umbrellas. Of course, in these days, you only do short-term forecasting. What you have to do is very short-term, but people won't buy what doesn't exist. So on the other side, you have marketing trends that will put big brands so that you're always asking for something that already exists. Okay, so that's marketing. So then you can enhance your inventory management. They can optimize inventory levels by predicting future demand based on patterns. See, the key word here is patterns. And that answers your previous questions. We're full of patterns. Just go home and then write on a piece of paper this evening, anybody in here, and myself included, we're full of patterns. What did we do today that didn't enter a pattern? What did we got up? Okay, that's a pattern. Maybe we took a shower, that's a pattern. Then we had the breakfast, and we always eat or drink more or less the same thing. That's a pattern. Then we went to work probably the same way as we did yesterday. So I would say 90% of our life is a pattern. So that's the key word of the previous slides where you're asking all these questions. Everything's in patterns. We always use the same words all the time. We always say the same thing. We think we're complex because we don't have a good memory. We can't remember a lot of what we do.
So what you do then in supply chain, for example, you would put a lot of these different input parameters, right, and feed the transformer to train, right, based on.
I wouldn't do no, I wouldn't do that. That's what I wanted to show you, because everyone reaches this conclusion, but I don't think it's true. I don't think it's possible.
Okay.
That's not how it works.
Right.
So I've been experimenting a lot and working a lot as a better tester for OpenAI, and I found something much better to do that everyone can understand. So you see here that you have all these numbers. Remember, I was saying you convert words into vectors. You can convert anything into vectors. Anything. Why would I call my dog a dog? I don't need to call it a dog. I can call it 26,834. I mean, it's arbitrary. So you convert everything in numbers. And here's what I suggest.
Okay.
I suggest that you understand what we just said up to now, because it's important, but you forget it for anything that's not language. So for supply chains, what's fantastic, remember I was showing you this example, you have Ali that is there, and if there's an apple, then we're going to move the apple towards him. It's like when you order something on Amazon, it brings it to you. It's because you paid it, you gave it away. So what I did in the early days, and for a very long time ago, but now it's become something very interesting at OpenAI, you can embed a concept with 2,228 dimensions. That is huge. So you can take the ID, the time, the product, the user, the score, the summary, the text, but then it has so many dimensions that it can imagine many, many parameters of what can come in there. And then you just stop it. You don't use it that way. You pull these embeddings out of there, and then you use them for other machine learning algorithms that are much simple to understand, like clustering, k-means clustering, nearest neighbors, regression, classical data science, statistics that you master. So what it does, it will give you some excellent relationships between all your data, but then you're bringing it to data science. You don't have to go to artificial intelligence in the deep learning sense. You can take it to very straightforward statistics. And you can even go further, because if you don't like those 2,228 dimensional vectors, you can convert them into principal component analysis, something that it's not that difficult to learn, and you have all the equations, which means that it's explainable. Principal component analysis is calculating the variance of a variable with an equation, then calculating the covariance of two parameters, then calculating the eigenvalues and the eigenvectors. And these are pure math calculations that you can trace all the way back to the original data. So this is very industrial, and this is good because with this, you can create all sorts of algorithms and even rule-based algorithms, because once you have you've reduced the values here to just a vector, its direction and magnitude, well, then you can do anything you want with it, even and with classical basic or anything you want. So what I would suggest for the industry, and this is how I implemented it in the early days, is let it, yeah, sure, give me the dimensions, but then get out of here, because no one understands what you're saying. No one will trust the system. Use it that way first, and use the natural language part just for, communicating marketing or support or simple things like that. But you don't want to go into a supply chain with a transformer, unless you'll end up in prison.
Yeah,
because
but
because
here you're saying you can use foundation model level embedding. So you're using the transformer
yeah,
indirectly.
but I'm using only the relationships, and it's
Okay,
created.
yeah.
I'm
Fair
not
enough.
I'm not taking its decision. I'll make the decision.
But
Because the
I'm using the
problem,
vectors, right? I'm
yeah,
using,
I'm just doing their vectors, and I control them, so I can see where the mistakes are. Then
yeah,
I can retrain it. Because if you trust it to make a decision, it's a big project, because you have to implement rule bases before and after, or it has to be wrapped. You can't use a raw transformer. It has to be wrapped in rules where you control the input and you control the output, because sometimes it hallucinates. It's a technical term.
hmm,
Now it hallucinates. It means that once it doesn't know something, it can invent it.
hmm,
So there's this lawyer in New York, maybe you heard of him, that was in a hurry, and he typed on ChatGPT, and ChatGPT invented a lot of cases that didn't exist. He
yeah,
went to court, and now he's being prosecuted because it's stupidity, because the system will hallucinate from time. But with dimensions, you can control it, because
hmm,
you can filter the output very easily. And now if you use a transformer, you have to wrap it up. You wrap up the input, you wrap up the output. And
hmm,
that's why I said at one point, I seriously doubt it will replace many humans, because you need a lot of human intelligence to wrap it up, to encapsulate, to control it. So it will help. It will diminish the work of some people, but it'll increase the work of other people. So there'll be a balance.
hmm, hmm.
So that was about what I had to say. I was just saying, can use it at every level of a supply chain, because today everything's going to be connected to everything. What
Yeah,
I'm saying is, contrary to what some California people think, or when they're in their house and they don't have to think about money or anything, they say artificial intelligence is going to destroy the world. Well, they have to realize that maybe 1 billion people don't have internet or electricity, that 3 billion people don't even use a computer. So what I'm saying is, it's impossible for industries to survive without automation, and this kind of automation to make decisions at warehouse level, at shipment level, but controlled, like I just said, not just letting it do what it wants. I think it will make economies grow, because we'll do machine to machine communication. And I know in Germany, for example, like Siemens does a lot of that with the windmills, with automating maintenance and stuff like that. It's it's not the extinction of humanity, it's the extinction of waiting times. People don't want to wait anymore. No one wants to wait. So we're not looking at the extension you meant, but the extension of waiting time.
yeah. One question,
All the questions you want.
yeah, people can even take, can speak, by the way, but I can also take them. There was one question. I work in data modeling and governance. Are there any reference use cases in these areas?
And governance of, in which case, governance
Data
of what?
governance, I guess, right? Data governance, data modeling.
Well, yeah. For me, governance is laws. for example, the European Union right now is passing a law. And that
Mm.
law says you can't do this, you can't do that, you can't do this, you can't store that data. Governance is a lot about legal problems.
Mhm.
And then what you can do for governance is implement, I would implement first rule bases,
Mhm.
classical SQL, SQL scripts that control to see if it's legal. Then you can do some machine learning if you want to find some trends,
Yeah.
but it's mostly legal. I would say 80% law, maybe 15% classical software control, and then maybe 5% of trying to figure out if someone's trying to trick me with some machine learning. But it's governance is law. You have to respect laws.
Then there's another question. Can hallucinations plus pattern recognition truly rival human creativity someday?
Now that's impossible
Okay.
because
So straight
because
answer.
because if I have there are several examples. You have Newton, for example. Everyone's forgotten about this person, but he was forgotten in his time because he was working a lot alone. And then someone says, "But how do these planets hang around together in space? How's that possible?" And
Mm.
they were thinking and thinking and thinking, and all of a sudden he says, "Gravity." But that didn't come out of anywhere.
Mm.
It just came out of his mind. And artificial intelligence is data driven with hardware. So if the data doesn't exist, it's not going to find something new. It's just giving statistics on something in the past. It's just like forecasting, except it's forecasting words or numbers. But it can't find something that doesn't exist at all because it's based on data and hardware. And then the second example is you have is a couple of centuries later, Albert Einstein comes along, and I don't know if you know this, but it really stunned me the first time. He says, "Well, Newton's a nice guy, but that's not how gravity works. And there's no such thing as the Earth being attracted by the sun." And I would say 90% of us, I didn't know this until a few years ago, but an astrophysicist explained it to me. He says, "Yeah, you're talking like Newton, but what you're talking about it doesn't exist anymore
Mm.
because Einstein just came that ex nihilo, and he said, no, that's not how it works. The sun distorts time space so that Earth is always going in a straight line without knowing it. But then since the sun is distorting it all the time, it goes around in circles without knowing it. And you can even put a cup of tea at the place of Earth that would do the same thing." I was extremely stunned when I heard this the first time. Now, only a human can find this. No machine is going to ever find something new that doesn't exist
So you think,
unless you transform that machine into a human, because humans have intuition, emotions, bodies, perception. So if you're recreating a human, well, I hope I'll be gone by that time.
one totally different question, much more down to earth, let's put it that way. How does a model can understand a request like summarize something? So we have, you give an instruction to a model saying summarize this text, and you give the text and then it comes up with a summary.
Right. Well,
Or,
that you know what? I was just working on that.
okay.
I'm working on it right now. I'm working on this right now. I took the algorithm apart.
Okay.
So the first thing it does, so I'll just sum it up, okay? I'm working on it right now. First, it will go through the text. It analyzes all these words together. Then it will find the key points, the weights. Remember, it will find the most important words used in that paragraph statistically. So it'd say, oh, he's repeating that all. Okay. Then it will remove. It's based on removal. We use intelligence to take what we think is interesting out. It will do the opposite and take anything that's not interesting out of the context. See, like if we say, "I'm going to eat apples today," we remember apples. but he's going to say, I don't care about I don't care about today. So it's more about subtraction of words that are not very important. Then it will, since it's a natural language thing, it will take these words that are left, and it'll build a logical sentence. Since it knows how to build sentences, it'll just do the statistics. And then for the key points, it notices, now this is terrible. It notices that humans are always talking to say, have patterns even when they write. Like many people begin a paragraph with the main sentence of the paragraph. So you can detect spaces and say, he's going to start something new, because we learned that. So basically what you remember is that it'll understand the words, it'll take the statistically low words out of there, and it will rebuild sentences since it knows how to build sentences. That's basically it without going into the math.
Yeah, but there are some models that are good at instructions, right? For example, summarize this, or give me that, or give me this, right? And some models that are not good at all. So do you need to train the model telling him?
Yeah, you have two models.
Yeah.
You have like T5, text-to-text Google. I'm working on it right now. It will learn how to summarize. You give it a tag, you say summarize, you give it a sentence, and little by little it learns it, but not ChatGPT. That's why you have two models that learn how to do something, and models that are just emergent or generative. And it brings it back to this puzzle that you'll be asking yourself all the time. Am I so limited and so repetitive and so full of patterns that a piece of hardware, an extremely simple math just distributed on multiple GPUs, can find all my patterns in repetition?
Well, one more thing, right? Do you think there will be a limit to adding more and more parameters? What do you think about other approaches like symbolic AI?
Well, that's where I come from. I come from cognitive science.
Yeah.
So this is the problem. I come from there. And I came from cognitive science, and I did expert systems. Because you're 100% sure that you can get the right answer after some time.
Yeah.
Then in the early 1990s, I hit rock, because I was working for a major German Belgium corporation, but there were too many rules. There were too many rules to find. I said, gee, and these people were working for several years. And I said, you've been working for years on something you'll never find. How are you going to find 2,000 rules? By the time you write rule 1,000, it's going to be conflicting with rule 100. So that's why you never succeeded. You have to do something stochastic and statistic.
Okay.
That I introduced the real Boltzmann equations in there, because that's how Boltzmann really did it. So I'm not going to go into that math, but then I introduced stochastic calculations, and then Henri Poincaré, the French mathematician, worked on that. So I used these equations. So I was getting to where you need these statistics, and then it will create what we call patterns, are in fact rules, if you think about it. An expert says, when you're writing expert systems, well, I do this, then I do that. Well, a pattern is something maybe implicit, but it's doing the same thing. So we will find patterns by itself when it becomes too complicated to do something. How can Facebook control 2 billion posts per day with rule bases? Well, that's not going to, it can filtering things and stuff like that, but to find it, it needs artificial intelligence that will find patterns. That's all we're talking about, patterns and statistics. And by the number of parameters is not a problem anymore, because you have different levels in the system. I've been working on this for years, even before these models, where you have there are research on trillion parameter models. Yes, but inside you have a mixture of experts. So at one point, it won't use those trillion parameters. I'll just use 1 million of them to solve a problem. So it'll specialize. It will say, if I take my example of before, I'll say Sahara, okay, just use those parameters. Apples, just use those. That just use that. So little by little, you're splitting the system up into very small pieces where it's just doing a simple calculation.
Mm.
It's like when we say the human brain is huge, but we just use a small part to do a task. But don't be mistaken. People say that we don't use our brain are completely wrong. We use 100% of our brain, because if someone's in an accident and uses, if there's part of the brain missing, the human is not functional anymore. So people that say we have this huge brain with this huge potential, we only use 10%. Sure, I'll take you to a surgeon. He'll take 90% of your brain out, and we'll see what happens. So we're using, for each task, we're just using part of our brain. And why do we say that? It goes back to the patterns. We do things that are so simplistic in our daily life that we say, I'm not using my potential. Sure, but you're using your whole brain because you couldn't go to work. You're just using it for stupid stuff. That's all.
Just one question that is interesting, a different topic, right? But maybe don't go to specific. Somebody was asking if Da Vinci was a better solution for corporate clients or governments than ChatGPT. But the question is, okay, are there better models for specific use cases?
Yeah, I'm sure of that. Because, for example, if you take a classification, Hugging Face doesn't meet the level of OpenAI or Google. It's impossible because of what I was talking about. I think Hugging Face has maybe $100 million in funds and all that. What are you going to do with $100 million? Nothing. You come along at OpenAI, they get billions at a time. So there is no good model, because I had this question asked many times when I went to companies, even before that, and I say, do you really need software? The first question is, do you need software? Maybe you don't. Maybe you can just reorganize a department and you won't need what you're asking for. Because if I know supply chains pretty well and I say, what are you doing that? Just for late delivery. If all your suppliers delivered on time, so why don't you just improve your delivery? Then I say, can you do it on a piece of paper? And some people say, yeah, I don't have much to do. I could, yeah, well, then do it. Can you do it in Excel? Okay. Then you build up from there. Can you do it with Hugging Face? Just with this small model, you just want some sentiment analysis to see if the customer is satisfied or not. Okay, I'll do that. Now you're building up. I have 10 million users. Oh, okay, let's go see Amazon, AWS. Let's go see Google. Let's go see Microsoft Azure or IBM Cloud. We're stuck here. Now, if you reach that level, forget about small models. You need these big, solid things that work. But the trick is that Google, for example, or Amazon, sometimes suggest to use very, very simple models. I tested k-means clustering for Amazon in one of my first books. I remember that in 2018. And at Amazon, I found that no one was using it. So I was one of the first using it, and I found a lot of things to improve. So I worked with the development team. It escalated, and I worked with them, and I reached the conclusion in that first book I wrote that I could solve a huge amount of problems with just a simple algorithm.
This is also what Andrew Henning is saying, right? Test your problem first with simple algorithms just to validate the scenario.
Always go to simplicity and then build up if you, well, yeah, it's logical. I mean, if you look at deliveries, people will deliver small deliveries with a small truck. And when it's a big truck, well, big, it'll go with a truck. And if it's big, it'll go with a cargo boat. Yeah, you have to, there's no the solution. It's the solution of your problem.
Anyway, we are running out of time, right? Just one last comment, because you said it's all statistics. Is our brain only statistics?
Nope. No. Our brain is not statistics at all. We use statistics to make decisions. Like we'll say, this person insulted me 10 times. I'm not going to be insulted.
Yeah.
But that is you just ask a fundamental question. We've been reduced to such a small amount of what we are that someone can believe that a machine can equal us? What about perception? What about emotions? What about love? What about emotional intelligence? What makes a team? You work in a company. What makes a team? Does a team make the best engineer? No. The team makes the best person that can cooperate with the person next to him. That's what makes a team.
Excellent.
If you hire this super engineer, wow, he's intelligent. But wow, is he dumb in terms of emotional intelligence? We can't work with this guy. Now you take someone average, but he has this super emotional intelligence. You're going to do great things.
That's
So
great.
a human being works in groups. We work in groups. We have emotions. We have perceptions. We know how to work together. We know how to do teams. We have a body. We can go to different places. We can unplug the electricity of all these systems. Now, before AI takes over the world, I live in France. The electricity will be shut down by strikers, and there'll be no. So explain how you can fall in love with a machine, and what's the purpose of a family with GPT in the middle of it? Nothing. So we've been reduced. I tell you, go back and look at modern times. We've been reduced in our daily lives to something so small that some people believe, actually, these California billionaires, that artificial intelligence is going to no, it's not. Because at the end of the day, what happens when the electricity goes off? What happens when there's COVID? What happens? And where are you going to get all the computer chips to make all these robots they're imagining? We have no rare minerals on the planet. There's a calculation in France that if everyone bought an electric car, we'd have to have 4 times the nuclear plants we have today.
That's right.
Now where do the chips fit in? I don't see. So I don't believe that at all. Of course, apart from this job, I'm a musician and I paint, and there's nothing comparable to that. So going to a concert, even of rock music or classic, and listening to someone play that real music. When you go to a concert, so imagine you go to, that will give you an idea. You go to a concert and the curtain doesn't go up. No, it stays that way. And you just hear artificial intelligence playing music. How good, everyone's going to tear that concert home, because what you're looking at is not the music. You're looking at Mick Jagger. You're looking at Beyonce, how beautiful she is, how she dances, how she moves. Sometimes I don't even care what they're singing. If you have these nice people dancing, or Michael Jackson when he was dancing, I didn't even listen to half of the words. So when you go to a concert, I'd say 1% is the music, and the rest is, how is this pianist playing? What's going on? So if you want to dominate artificial intelligence, expand your perception of who you are, and remember, it's just a calculator. And at that point, and that unfortunately in our daily life, there's a lot of patterns, but we're worth a lot more than that. I mean, a lot more.
That's going to be your final word. I think it was a good final word, right, Denis? Always captivating to listen to you and speak with you. It was great again, right?
Thank you. It's when you want, no problem.
I'm so happy we did it the second time. I think last time was 2 years, 2 years ago.
Sure. Because all these questions make me think, because only humans think.
Thank you, Denis. Thanks so much. Have a nice evening.
Have a nice evening, everyone. Bye-bye.
Thank you, everybody.
Thank you.
Bye-bye.
Bye.